Hello and welcome everyone to week 6 of the 17th semester or iteration of the massive open online course for the University of Nicosia's master's degree in digital currencies. This week, unfortunately, I'm recovering from COVID. Shortly after our last session, last Thursday, I started having symptoms. And while most of them have gone away, I'm still coughing a lot and I'm very weak. So I can't promise this is going to be a very effective session. We might have to go shorter than usual. And I'll try to mute my microphone as quickly as possible if I have any coughing fit or I'm about to have any coughing fit. We'll see how my voice does. Well, we've got lots of great questions from the forums, so let's get started right away. Daniel asks about proof of work versus a proof of stake. We had plenty of questions about that. One of the questions I encountered frequently is how to communicate the value of energy inefficiency by design in proof of work cryptocurrencies. This seems poorly understood by the public at large, who look at any blockchain energy consumption as energy waste. Given this, what, if any, do you view as the key advantage of proof of work over proof of stake? In key characteristics such as decentralization, immutability, and censorship resistance? And in what scenarios would you see proof of work as better? And in which scenarios would you see proof of stake as more effective? All right. So in order to characterize something as a waste of energy, you are showing a hidden assumption. So the question about whether it's a waste of energy or not depends on whether you see the thing that that energy produces as valuable or not. It's only a waste of energy if the energy that is used is worth more than the thing that is produced by that energy. From a scientific perspective, energy is only converted to heat. Presumably heating your home in winter is a waste of energy if that heat is converted to heat energy, and that is the lowest form of energy. It's not recoverable. It's heating our planet unnecessarily. Put on more clothes. But of course, you see value in living in a home that is warm. You see value in comfort, and you see that as a worthy cost. So the issue here is very much about our normative understanding and subjective value of the output of this energy. So let's take a step back and see what exactly are we getting with that energy? What is the thing that is being produced when energy is used to do proof of work? The answer is security. What proof of work is producing for us is security. It's producing security for the blockchain for which the proof of work algorithm is running. So for Bitcoin, for example, we can say that that energy is going towards securing Bitcoin, securing those transactions, ensuring that you can't cheat in the system, that your money can't be stolen, freezed, seized, or stopped in any way. So it's also buying us some of the characteristics that we get from the decentralized nature of that operation. So we not only get security, we get security in a decentralized model that also offers us censorship resistance. Now, the Bitcoin economy itself is almost $1 trillion. So therefore, is that energy wasted if it's securing almost $1 trillion in value? And arguably, the answer is no. Really, if somebody, however, says that it's not actually worth anything, it's useless, and then obviously any energy, any amount of energy, any effort spent to secure that is wasted. And so you can't really make a rational argument if you have a fundamental disagreement about what the value of the system is and whether the system is worth using energy for. The idea that proof of stake is an alternative that is just as good as proof of work, only it doesn't require any energy, in my opinion, isn't true. And so one of the reasons why I think proof of work is necessary, at least in the case of Bitcoin, is because what proof of work gives us is the ability to validate the history of the blockchain without external reference. Meaning that if you want to change the past of a proof of work blockchain, you have to spend the energy again. Let me be more clear about that. Let's say you are currently at 700,000 blocks and you want to rewrite the last 100,000 blocks of the Bitcoin blockchain. Well, rewriting the last 100,000 blocks, approximately 2 years worth of blocks, will take as much energy as it did to record those 100,000 blocks in the first place. That's a lot of energy. So as a result, you cannot inexpensively overwrite the past. And it doesn't matter whether you have 1%, 51%, or 100% of the hash power. This is a very important point to understand. If miners in full agreement with 100% of the hash power decide to overwrite the past, they still must spend the amount of energy required by the difficulty calculation over the past so many blocks that they want to overwrite. They must still spend that energy. There is no way they can simply ignore the rules of the difficulty algorithm or the requirement to do valid proof of work. There's no shortcut to doing the proof of work, and you can't simply change the rules. Even if you had 100% of the hash power, you can't change the rules. All you end up doing is forking and creating another coin. So compare this now to proof of stake. Proof of stake allows you to reach consensus on the truth of the chain and to move forward into the future based on the allocation of capital by those who have this capital in the form of the cryptocurrency. So stakeholders, people who have, let's say, for example, ETH, could stake that in order to ensure the future of that chain. And bear in mind, ETH is a proof of work chain today, although ETH2 is a proof of stake chain. So the current implementation of Ethereum is not proof of stake, it's proof of work. Assuming you have a proof of stake chain, those who have cryptocurrency can use it to allocate it in order to guarantee the security of the chain going forward. However, if 100% of the participants agree to make changes to the past, they can do so at zero cost, meaning that a consensus attack by the stakeholders against the history, the past of the chain, has zero cost. Whereas in a proof of work algorithm, even if you had 100% of the miners agreeing, they still have to spend the energy in order to overwrite the past. To me, that is the fundamental difference. Now, many people who are in favor of proof-of-stake blockchains will say that social consensus, the ability to consult and coordinate with other nodes to decide what exactly happened in the past, to have a degree of trust in the information you receive from the community, from other nodes, the ability of developers, economic actors, etc., to coordinate their interests is sufficient to maintain clarity on what happened in the past, and you don't need energy to do that. But in the proof of work algorithm, the idea here is that you don't need to do any trust or any coordination. If you see a chain that has the necessary proof of work and the energy has been expended, you can trust that that is the correct history. My node can reconstruct the correct history of the Bitcoin blockchain with no reference to any external source other than what is in the blocks themselves, and know authoritatively that that is the correct chain simply because the amount of energy that's gone into it is monumental. and that is a security characteristic. Now, it's expensive. It's expensive if what you want is a degree of immutability, robustness, and resistance to social manipulation that is higher than anything we've ever seen on this planet. If you want a truth that has a monumental amount of work. I've actually done a talk on this, which is the thermodynamic model for proof of work. The idea that proof of work constructs a monument using the laws of thermodynamics, using energy, an energy monument to truth. That is the Bitcoin blockchain. And you can't fake that. Just like the pyramids state that the people who built them had enormous resources in order to construct that monument, the Bitcoin blockchain is a monument to truth that cannot be faked because it takes energy to build. And that in itself is very valuable. However, it's also very expensive. So the question is, how many of those do we need? There's a very good argument to be made that if you have one proof of work blockchain that preserves the monument of truth, you can actually checkpoint and secure many proof of stake blockchains that can use the proof of work monument in order to checkpoint the past. Therefore, making it expensive to overwrite the past of the proof of stake chains, because that past is recorded also as a hash, a checkpoint hash at regular intervals in the proof of work chain. All right. So proof of stake is more nimble, it's more flexible, but it provides a lesser degree of absolute security and absolute truth, especially when it comes to the cost of rewriting the past. It doesn't scale as well. It scales better than proof of work. Proof of work does not scale as well, but proof of work gives us a degree of immutability that is greater than we have ever had in any technology in the past. As a follow-up question, Hassan asks, when ETH upgrades or downgrades to proof of stake, will the mining stop? And how is the miner rewarded? So this goes along with another question we have from Philip from the forums, which is the sum of the fees in proof of stake, which a validator can earn for each block, capped by the amount of stake? And could you explain how the stake is actually locked? So there are many different ways of doing proof of stake, but in very simple terms, the way proof of stake works is you deposit a certain amount of the cryptocurrency called the stake into a smart contract, into some mechanism that effectively locks that capital away for a period of time. And that period of time is usually much longer than the amount of time that you are actually validating the blocks. Because if you were able to unlock that money after you validated the blocks, then you could then immediately go and rewrite the chain. So you have to have that kind of forward resilience to consensus attacks. And so you have money that you lock into a smart contract. So what does that mean in practice? In practice, it means that you send that money to a smart contract. Now, in the staking process, your node will collect information about the blockchain, transactions, etc., from other nodes in the network, and then it will provide a digital signature of validation for a specific block of transactions. So it will attest certify, if you like, a specific block. And this, again, can be done in a variety of ways, but the most straightforward is you do a digital signature on the hash of the block, and then you submit that to the smart contract for validation. Now, if everybody else who's also validating the block validates it the same way that you validated it, then in proportion to the amount of money that you staked, you can receive a small amount of reward, which is effectively from transaction fees or from block subsidy, meaning new currency being issued, that gets distributed to all of the people who had locked stake and did validation during that time. Now, there are a number of different ways this can work in practice. In some blockchains, for example, you can delegate the validation. So you lock your stake, and then you point at someone else to vote on valid blocks on your behalf. Obviously, you have to trust that this person will do it well. If they do it well, you earn stake. Now, what happens if they don't do it well, or if you don't do the validation well? And that comes the penalty part of staking. Most of proof-of-stake systems have a mechanism called slashing. Slashing is where you are penalized, where you lose part of your stake. So effectively, you get a reward if you validate correctly. But if what you signed or validated is different than what everybody else validated, or you fail to validate, you're offline for a period of time, then you lose part of your stake, almost like a negative reward, a punishment. And again, that can be a proportionate amount depending on either how many blocks you gave invalid answers to or how long you were offline, all the way up to and including losing your entire stake in some staking protocols. And again, the details of how a proof-of-stake system works depend on the implementation. And you'll see how in different proof-of-stake algorithms, these details have been tweaked, these various design considerations, how much you have to stake, how long you have to stake it for, what happens if you're online, how much you gain, how much you may lose in the case of invalid security that you provided, whether you lose stake if you're offline for a period of time, how long, and how much you lose. All of those things are really tweakable characteristics of the proof-of-stake algorithm. So to answer also Hassan's question, when ETH upgrades to proof-of-stake, the mining stops, meaning the current proof-of-work algorithm that's done with GPUs, farming, hashing away in these big mines, producing validation for Ethereum 1, for ETH's traditional proof-of-work algorithm, that is no longer necessary. The entire Ethereum 1 chain gets swallowed or migrated as a whole into ETH2 and then runs as one shard, potentially, that is validated in parallel with other shards as part of a proof-of-stake system. So currently we have both systems running at the same time. First we had Ethereum 1 proof of work, then Ethereum 2 was bootstrapped, then Ethereum 2, the beacon chain started running, then Ethereum 2 validation with proof of stake started, and the validation contract, and now both are running in parallel, and eventually ETH1 gets sucked into ETH2, and the validation contract that's already running on ETH2 continues to validate instead of mining. So instead of mining, staking. Miners who were previously using GPUs to mine Ethereum will either leave the industry, or more likely they will switch their GPUs to mining some other cryptocurrency that uses proof of work that is not Bitcoin. Keep in mind, Ethereum's proof of work mining, it happens with GPUs, not ASICs. It's not SHA-256 on purpose so that it's not specialized in ASICs. Those GPUs cannot be switched to mining SHA-256, not because there's any technical limitation, of course they can, but they are so inefficient by comparison to ASICs that it would be completely unprofitable for the amount of electricity that you would use with those GPUs. So when those GPUs are no longer interested in mining Ethereum, they're going to be mining another cryptocurrency that is not SHA-256 based, that is not based on the Bitcoin algorithm. And I'll go for another question from the chat, because I think this is a relevant question, which is one of the key points here. Iran asks, does proof of stake create a barrier for participating in the economy? In the future, only very rich parties with lots of coins can mine and get rewards. Well, that's a very good point. The minimum amount that you must stake to participate in staking, not counting the technical knowledge you need or the ability to have a node that runs 24 hours a day on a stable internet connection so that you can do the validation, etc., etc. All of those requirements pale in comparison to the minimum amount of staking. Now, in Ether, that was set to 32 ETH, which, by the way, at the time that that was set, was not an astonishing amount of money. It was the amount of money that buys you a car. Now it's the amount of money that buys you a house in many places. So a very, very big difference. Or if you like, it went from a small Toyota to a nice Lamborghini. And so that's the other thing, which is that the staking amount is denominated in the cryptocurrency, and that means that the minimum participation changes over time and can become very, very high. So 32 ETH at current prices, what is that? Let's say 75,000 US dollars, and I'm doing arithmetic off the top of my head, but you can do the math. That's a very large amount of money, which means very few people can actually do that. And this is one of the criticisms that's levied against proof of stake. Now, you might say, well, proof of work also requires you to own hardware. In the case of Ethereum, that means buying a graphics card, and last time I checked, even an RTX 3090 did not cost $75,000 unless you were very desperate and bought it from a very dodgy person on eBay. So with a GPU, you could mine for considerably less, and that was part of the appeal. It was a more democratically accessible avenue to participating in cryptocurrency. And even with ASICs, a suitable ASIC rig can cost less than $10,000. So again, significantly less than the cost of the stake. So that may change over time, of course. Maybe in the future, the amount that's required to stake is less. But one of the things that proof of stake clearly does is it allows those who have money to earn more money on top of it through a process of effectively rent-seeking or interest earning, a return on investment based on their provision of security in the network and capital. It allows them to deploy capital in order to make more capital. It's a very capitalistic mechanism. And what we've seen is that it is very likely that it creates the conditions where it's very difficult to get enough money to get into that game. But once you're in that game, and your money makes money for you, then the rich get richer, right? So you get that kind of criticism for proof of stake. The criticisms for proof of work are different, no less valid, of course, both on the environmental impact of doing mining from sources of electricity or energy that are dirty in themselves, meaning they produce CO2 in large amounts and pollute the environment. And of course, access to hardware has been a limiting function for those who want to participate in proof of work. Here's a very interesting point, though. If you wanted to start a proof of stake system today with a cryptocurrency that was just invented, and you have a system whereby anyone who owns the cryptocurrency can then use that to do validation and security. But in the beginning, no one owns the cryptocurrency. And so, therefore, how do you bootstrap a proof of stake system? This was one of the arguments to why Ethereum wasn't bootstrapped from the beginning as proof of stake, and why it's actually quite difficult to bootstrap a pure proof of stake system, because if you simply allocate the capital to the founders, the developers, whoever started the project, then they're the stakeholders, and you've already created a very, very centralized system. So the idea is, one of the ways to bootstrap a proof of stake system is to bootstrap it as proof of work, allow people to generate the currency in a very decentralized way with an easy to mine proof of work algorithm that can be done at home on a laptop with a GPU, etc., before big players get in and realize that this is worth doing. And then you transition to a proof of stake so that the people who participate as stakeholders are people who generated the currency on their own, and therefore you have a distribution, the initial distribution of the currency through proof of work, and then that currency can be used for proof of stake. In all of these discussions, one of the terms you'll hear coming up very often is the Gini coefficient. And the Gini coefficient is the idea of looking at wealth inequality within a system. And cryptocurrencies certainly suffer from, in some cases, extreme examples of wealth inequality. The question, of course, is, do proof of work or proof of stake systems make the Gini coefficient, make the wealth inequality worse or better over time? And if you have a proof of stake system that you try to bootstrap through an initial distribution, a pre-mine, if you like, to the developers, then the end result of that will be that you start off with a very unequal distribution of the capital, which through a proof of stake system isn't going to get any better over time. All right, let me quickly check in the chat. I see we've had some people expressing spicy opinions in the chat that are not adding to the conversation. And just so you're aware, we do have the ability, obviously, to moderate this chat, and I'm not interested in sidetracking debates or arguments. So first warning, you're going to have your message removed, the message that is not adding to the conversation. Second time, you're going to be timed out for 5 minutes, and the third time, you're going to be permanently banned from the channel because you do not have the right to disrupt my class. Pretty much like a classroom, which is if you're in my classroom and you're being disruptive and not adding to the conversation, I kick you out of the room. All right, so let's talk a bit more about proof of work. Alex has a good question. How can we stop a Sybil attack in a proof of work system? A Sybil attack is an attack where people launch many sock puppets or fake systems that have no presence, virtual machines, Amazon cloud computers, or multiple accounts. So Sybil attack is the general term used for a type of distributed denial of service attack where people create many fake accounts, like, for example, many fake Twitter bots or fake Facebook accounts, or create many virtual machines that pretend to be doing something useful, etc., etc. you do not need to stop a Sybil attack in proof of work, and the reason is very simple. You have to, in a proof of work system, you have to prove you did the work. And therefore, if your system that you've set up is doing the work, it is by definition not a sock puppet. It's not an empty, worthless, effortless account. You can't do effortless denial of service attacks in a proof of work system because proof of work requires that you prove you did the work, and you do that by producing hashes with specific target outputs or patterns in them that can only be achieved by repeatedly hashing and changing the input. So that ensures that you can't do a Sybil attack in proof of work. Can you do a Sybil attack in proof of stake? Where you make lots of anonymous wallets? Well, no, for the same reason, because those wallets have to have economic value behind them, and their contribution to the validation and security of the chain, as well as their contribution or participation in the rewards or penalties, is proportionate to the amount that they are putting behind that account. Even if you didn't have, let's say, a 32 ETH minimum as an example from ETH.2, or pretty much every staking algorithm has a minimum amount that you have to stake, even if you didn't have that, the smaller the amount, the less your opinion about validation matters, the less you participate in rewards and punishment, and therefore you're not really participating. So setting up lots of wallets without putting funds in them doesn't achieve anything, because it's not the wallet, it's the ability to lock the funds and commit them long term. So you're using the funds to attest as a bond of security against which your validation results will be taken seriously or not. All right. Now the next topic we have is smart contracts, and then we'll look at the different types of blockchains, including federated and hybrid blockchains, to stay on topic for this session. And then if we have time, I'll go back and answer more questions about proof of work, proof of stake, consensus algorithms, and the competition between them. All right, our first question comes from Hassan, who asks, how is the smart contract code stored in the Ethereum blockchain? Is the code itself stored inside the block? And the answer is yes. So when you want to store a smart contract, the execution code, which is effectively compiled into a bytecode that is suitable for execution by the Ethereum virtual machine. This is a binary. It's a bytecode binary. That is submitted as the data component of a transaction that you send to a specific address within the Ethereum system, which is the 0 address, which is used as the contract registration address. So if you construct a transaction and you send it to the 0 address with the bytecode of a contract, the Ethereum system records that transaction in the block, and that transaction becomes the contract address. So essentially the address of the transaction, the ID of the transaction, is the contract address, where you can then execute that contract. So essentially you register the contract by incorporating it into a block with a transaction, and all of the code of the smart contract is written to that block when you first register it. That's why the cost of registering a contract is higher than let's say a simple payment or contract execution, because it carries quite a bit of data with it. Obviously, the bigger the contract, the more code you try to register, the more you have to pay in Ethereum, because it's recorded in the block. Yes, and that takes up space in the block itself. So in Ethereum, blocks are not limited in size in terms of bytes. They're limited in terms of the amount of gas that can be consumed to construct the block, essentially the amount of execution time that the Ethereum virtual machine will execute per block. And registering a contract and the data storage costs of that contract cost a certain amount of gas. And therefore, you have to pay the amount of gas to do that, and that amount of gas has to fit within the allocated amount of gas for that block. So if you try to register a contract that's very large, not only will it be very expensive, but if you exceed the gas limit of the block, then it will fail. You're still going to get charged, and you will be unable to register that contract. So in Ethereum, you've got to consider it this way. All resources in Ethereum are metered, meaning you pay for them. There is an accounting mechanism, and you pay for all resources. You pay for computation, you pay for data storage, you pay for transactions. And those payments are the transaction fees in gas. And at times, they can get very, very expensive, even for simple transactions. On a similar topic, pardon me. Today, my Not Your Keys, Not Your Coins mug does not contain beer, but instead it contains chamomile tea. I'm trying not to cough here. All right, let's continue with this line of questioning. Arnaldo has two questions. First is, RSK is the network of smart contracts in Bitcoin. How does it work? And is it not possible to build smart contracts on the Bitcoin mainnet? So RSK is effectively a federated sidechain, and it basically is a separate chain that is pegged to the Bitcoin chain so that you can move tokens from Bitcoin to RSK and back. And RSK itself has a virtual machine that executes smart contracts very similar to Ethereum. So it is one possible smart contract chain that you can connect to Bitcoin as a sidechain. It's not the, it's the first, it's the most prominent, but it's not the only one. There could be others. I don't know if anybody's built another one, but certainly there's nothing limiting others from building other smart contract sidechains that they connect to Bitcoin. So how does it work? Well, without trying to simplify too much, you could say that it works very similar to Ethereum. So it's very similar in terms of its compatibility with the virtual machine and the use of Solidity code for creating smart contracts. So and that's intentional so that developers who have experience with Ethereum can make an easy transition into RSK. The difference, of course, being that you can move value from the Bitcoin blockchain into the RSK blockchain and back through this two-way peg. And that means that you can relate the execution of these smart contracts to the Bitcoin. Then the next question from Arnaldo is it not possible to build smart contracts on the Bitcoin mainnet? Well, it depends on what you mean with the word smart contract. If what you mean is small programmable execution within the Bitcoin system, then yes, of course you can. Bitcoin script that is used in transactions is a form of smart contract. It's a very simple form of smart contract. And with that, you can build things like complex multi-sig, conditions, time locks, and things like that. You're very limited in the extent of the things you can build. However, with enough imagination, you can build rather interesting smart contracts in Bitcoin on the mainnet. For example, one of the very interesting smart contracts that you can build in Bitcoin with Bitcoin script today is a bidirectional payment channel network called the Lightning Network. The Lightning Network uses Bitcoin transactions and the Bitcoin script within them to construct smart contracts that allow two parties on the Lightning Network to agree on the operation and conditions for funding, using and closing a payment channel, a bidirectional payment channel without expiration that can transmit payments in the form of hash time lock contracts, which are small smart contracts written in Bitcoin script that are executed inside Bitcoin transactions that may eventually be on the mainnet. If you close the channel, they have to be, and that are therefore executed on the Bitcoin mainnet. So, can you execute smart contracts on the Bitcoin mainnet? Yes, and we do, and that's what the Lightning Network is. It's effectively a series of 50,000 two-person side chains that use smart contracts on the Bitcoin mainnet in order to operate. But not in the way that most people mean the term smart contract. So when people say smart contract, what they mean is a programmable system, and they usually mean programmable to the full extent of general purpose computing, meaning Turing complete. So a Turing complete computing system is one in which you can have loops and or recursion, and this allows a program to run in an infinite variety of ways and continue to run for an infinite period of time. So Turing complete code can run forever. Bitcoin is designed on purpose not to do that, to be too simple to do that, so that it can't run forever. That way, Bitcoin doesn't need an accounting and metering system like gas, and it is much more simple to secure. However, as a side effect of that, Bitcoin can't do the kinds of flexible, interesting, creative uses of smart contracts we see with Ethereum. And so then the question is, pardon me one second. Then the question becomes, should we want to run smart contracts on Bitcoin? Should we want Bitcoin to be Turing complete? And my argument would be no. There's a number of reasons for that. The first one is that a Turing incomplete system has properties of deterministic computation, meaning that you can decide in advance how long something will take to run, whether it will stop executing at a certain period of time, and you can simulate the entire execution of the script and analyze its behavior before you run it. It also means that there are less possibilities for side effects within the code that can cause various security concerns. That means by keeping it simple, Bitcoin can be much more robust and secure than a Turing complete system. So Bitcoin has used a simple scripting language so that it can be extremely robust and secure. For Ethereum, the trade-off is different, and for every smart contract platform that's followed in that path of Ethereum. And the idea is that in order to gain flexibility and expressiveness in the programming language, Ethereum sacrifices the simplicity, deterministic computation, and potentially robustness and security of Bitcoin. And you're going to live with a lot more bugs, a lot more security vulnerabilities, a lot more unexpected side effects things like reentrancy problems that we've seen in Ethereum that you wouldn't have or you don't have in systems like Bitcoin. So therefore, the argument here is that Bitcoin doesn't want to do smart contracts because it's not secure to do smart contracts, and Bitcoin would rather be secure than be flexible. And Ethereum would rather be flexible than be as secure as Bitcoin. And that's a reasonable trade-off. In the end, in my opinion, these things represent fundamental design trade-offs where you can't eat your cake and have it too. You don't get both sides. You have to choose. Do you want simplicity and robustness and security? If so, you're not going to be very flexible. Or do you want flexibility, creativity, and expressiveness? If so, you cannot run as securely as the simple system. And so for some applications, it makes sense to have the flexibility, and for other applications, it makes sense to have the robustness and security. Bitcoin doesn't want smart contracts, shouldn't want smart contracts beyond the simple ones that it has. And trying to add them, in my opinion, is a bad idea. So that's why you don't have them. Some follow-up questions on smart contracts very briefly. Does the EVM allow the contract to connect with external resources or applications? And would that require whoever is running the EVM to allow such connectivity? All right, I'm going to go through this very, very quickly, but here's the point. There is no the EVM. There are many EVMs, meaning that every Ethereum client and every Ethereum node has an EVM in which, in order to validate a transaction, it executes the smart contract. When I'm running an Ethereum node, when I'm running an Ethereum wallet, I'm executing the smart contract to validate the transaction. Every transaction I validate, I execute the smart contract in my EVM. Meaning that you have to have an EVM running the same code for every node that is validating the transaction on the network. And that code could run for a while. It could consume a lot of resources. You have gas to ensure that it doesn't run for too long, but the people who are running nodes that are not mining don't earn that gas. They just know that because the gas cost exists, the smart contract isn't going to consume all of their CPU and memory, but it will consume some CPU and memory in order to run all of the smart contract code. And so the EVM can only rely on the information that is part of the consensus rules of the validation system, meaning that all of the information that is in the blockchain. It can refer to other smart contracts, it can refer to transactions, it can refer to the transaction you just sent it, and that's it. It can't go outside of that because those things are not subject to consensus, and therefore it might not get the same answer as everybody else, which is more broadly why all of your smart contract codes can only refer to information that exists within the blockchain. This is also known as the Oracle problem. The Oracle problem is, how do you know if a real-world event did or did not happen if you can't refer to anything outside of the blockchain? One way you can do that is by putting information on the blockchain for other smart contracts to use. Like, for example, you could record the temperature of some location for an insurance contract and record that on the blockchain in the smart contract, and therefore you can refer to that information in your decision making in your code. But that's no longer decentralized. That's a centralized source of information. So that becomes complicated. Generally speaking, the Oracle problem is one of the biggest problems you have with smart contracts. It's not an insurmountable problem. It just means that you have to be very creative as to how you construct smart contracts, and it imposes limitations on what smart contracts can do. So very good point, and a good question to highlight that point. Eduardo asks, how is the gas limit calculated and how long do contracts run decided? The gas limit applies to blocks, so the total amount of computation that can happen within a block, and that's to restrict the absolute ceiling amount of all of the transactions combined. That is calculated by the mining algorithm and adjusted periodically. You can think of the block gas limit as being very similar to the difficulty limit in Bitcoin, or the block size limit in Bitcoin, but it uses a dynamic algorithm to calculate that. Separately, however, a transaction has a gas limit. So when I make a transaction on the Ethereum network, I'm going to specify within the transaction the maximum amount of gas that I'm willing to pay, as well as the gas price I'm willing to pay to have that transaction executed. And if during execution of that transaction it exceeds that gas limit, the transaction is terminated, insufficient gas is returned as an error, and I'm still charged the fees for that up to the gas limit, but I don't get my transaction executed. So, two gas limits. There's a per transaction gas limit that when sending a transaction you put in that gas limit. That's effectively the same as how much fee you're willing to pay. And then there's separately a block gas limit, which is for the aggregate of all the transactions, which limits how much computation can happen in a block. Pardon me there, had some coughing. All right. NFEOC asks, as of today, is there any country in the world where smart contracts are admissible in court? No, but mostly because that concept hasn't been brought to a court. But many countries do have the necessary legal infrastructure to recognize things like digital signatures, as well as various types of agreements. Agreements don't have to be written in a specific form. Generally speaking, any legal system that allows for verbal agreements, written agreements, and other forms of agreement, and recognizes digital signatures, would probably have room for it to be difficult to dispute the outcome of a smart contract. But again, the question is, what does it mean for it to be admissible in court? A smart contract is a program, and that program executes on the blockchain and pays Bob or Alice based on the outcome of its execution. So in order for you to arrive in court, you would have to complete that process. You put money in, you sign transactions, you voluntarily participate in the execution of this mechanism, and then the result of that mechanism is that you didn't get paid and somebody else did get paid, and then you have a problem with that. You want to go to court. The whole point of a smart contract is the smart contract gave you a decision and paid you or the other person, and you don't have to go to court to figure out who won the money. But ultimately, if you disagree with that decision, you have a whole lot of problems, including what court So where do you have jurisdiction? You probably have jurisdiction where you live. What about where the other person lives? And secondly, who are you suing? It's a bit difficult to sue an abstract entity, although people have tried, and it's quite amusing when they decide to sue, Santa Claus, Jesus, the Tooth Fairy, etc., for cheating them. But in many cases, in order to bring action to a court, you have to show actual damage. You have to show that you belong in that jurisdiction, you have standing in that jurisdiction, and you have to have a cause against someone specific. And so that makes things a lot more complicated. So the real issue isn't the admissibility of the smart contract, which arguably is probably the easiest part. There are a lot of other issues as to whether you want to take this to court or not. But it doesn't seem to be very different from other types of financial disputes that involve software. Software is involved in transactions all the time. If your online banking system makes a mistake in a wire transfer and takes money out of your account or doesn't put enough money into your account, and you can't resolve that with the bank, you go to a court. Now, is the software of their online banking system admissible? Yes, it's admissible because it's involved in that dispute. There's no magic thing about the fact that that software was a smart contract running on a blockchain. The real issues are the decentralized nature, the fact that it runs across multiple potentially jurisdictions, and that there may be many parties involved that you don't know who they are because they do not need to identify themselves to enter into this transaction with you or with a smart contract. All right, so we can probably go for another 10 or 15 minutes. Let's see how it goes. Bradley asks about private blockchains and hybrid blockchains. Will we see platforms like Ethereum dominate the blockchain space, or will we see major expansion in the future for more private and hybrid blockchains? Similar question. Jonathan asks, are other blockchains that aren't public or permissionless truly blockchains, such as consortium or enterprise blockchains? Couldn't you agree that these are just centralized or semi-centralized databases? In other words, it's a centralized database that's immutable, somewhat distributed, maybe by a consortium of banks. Given the blockchain was created as a term in the last decade, are we misclassifying the term or taking liberties as to the true meaning of it in the pursuit of marketing? Well, thank you, Jonathan. What a fun topic. The word blockchain is completely meaningless. It's useful as a term of technology if you are speaking about a series of transaction blocks connected to each other by reference to the hash of the parent block, creating an unbreakable cryptographic time-stamped chain all the way back to the Genesis block. That is really a recording of the activity of a broader system. A blockchain is an artifact. It is something that is created by a decentralized consensus mechanism. The blockchain is simply the recording of this sequence of blocks that tell you what happened, more like an audit trail or ledger. And as such, the blockchain itself is a database. Although many people have a copy, and because these copies are all synchronized and point to the same answer after a while, due to the consensus algorithm, we would probably call it a decentralized database. But the idea that blockchain is this magical technology that gives you immutability, decentralization, etc., is meaningless. Because blockchains are not decentralized and blockchains are not immutable. Some blockchains are. if the consensus algorithm that is used to construct them produces immutability and decentralizations as the effects of its operation, produces these blockchains within a context that we can call decentralized and immutable. The blockchain itself isn't decentralized or immutable, and you can construct a blockchain that is very centralized and very mutable because anyone can change it or someone can change it. I can construct even a Bitcoin blockchain on my own laptop that I mine myself based on my own consensus rules that I choose to call the Bitcoin blockchain. Nobody else agrees with me, but that's okay. That blockchain is centralized. There's only one copy. It is not immutable because I can change it anytime I want, and it has one participant, me. So is that blockchain anything more than a single centralized database? No. So the word blockchain doesn't actually mean anything unless you start asking additional questions. If someone says this is a blockchain, then your next question would be, what kind of a blockchain? It's a bit like the word natural or the word vegetable. It doesn't really mean anything. In the US a few years back, the Department of Agriculture reclassified pizza as a vegetable so that school lunches that had pizza could be considered healthy because they contained a serving of vegetable. Yeah, sure, but that's not the meaning of vegetable most people have. So the word blockchain is entirely a marketing term. Unless you're using it in the context of speaking about a specific blockchain, a specific implementation, and you're talking about the characteristics of that implementation, meaning you're using it in the context of computer science, not in the context of economics, not in the context of technology marketing, or anything like that. So let's move further on. If you take that term and you make a system where a consortium of banks or a government in the form of a centralized central bank digital currency, a CBDC, which we'll talk about in a couple of weeks, or a hybrid, which is some kind of federated model between multiple participants in a consortium, such as Hyperledger or Corda, do those have the characteristics that we usually assign to blockchain? And again, when you say this is a blockchain, I have questions. You haven't given me any answers. You've just given me more questions to ask. So then I start asking, is it revolutionary, immutable, public, collaborative, open, resilient to censorship, and decentralized? I use an acronym to remember that, which is ripcord, like when you have to pull the parachute ripcord to save yourself from a collapsing economy designed for other people's best interests. That's the kind of ripcord: revolutionary, immutable, public, collaborative, open, resistant, and decentralized. Now, why do I ask those questions? Because I think those questions give me a good starting point to decide if what you just called a blockchain is interesting to me. And those are the kinds of questions I want to ask. You'll notice that profitable wasn't in there. And you'll notice that surveillance wasn't in there, and many other desirable characteristics that other people might desire. For me, it's only worth doing, and I say worth doing because blockchain technology as a whole is a very inefficient way of doing something we already know how to do. We know how to build distributed databases. If you want a distributed database, Microsoft SQL Server or Oracle will do very, very nicely. Even an open source equivalent like MySQL or MariaDB or even a NoSQL database like Mongo will work well. And you can even replicate and distribute and update and synchronize these things very, very efficiently without limitations to scaling and with very, very high transaction throughput. You can also apply cryptography to these things. You can add digital signatures. You can do all kinds of interesting things. Why would you use a blockchain? And the answer is the reason Bitcoin used a blockchain was in order to create the conditions to have robust decentralization, censorship resistance, and many other properties like immutability. In order to do that, it paid a very heavy price on the ability to do as many transactions per second as it wanted to. So a blockchain is a very inefficient way of doing things unless what you want is robust immutability, censorship resistance, and decentralization. You want something that can withstand being attacked by even large organizations or coalitions of governments. And for that, a blockchain makes sense, but it doesn't make sense for most of the other applications that people are throwing around blockchains. If no one's trying to censor you, you don't need censorship-resistant technology. You don't drive an M1A Abrams tank to the supermarket unless someone is firing rocket-propelled grenades at random cars on every Saturday. You do not need that level of armor because it's heavy and fuel inefficient and noisy and uncomfortable. So for all of those reasons, you need the right tool for the job. In my opinion, hybrid and consortium and private blockchains are a solution in search of a problem. I said that in 2015. I said that in 2015 when the first examples of these started emerging, and I said these will go nowhere. They will produce a whole amount of smoke and proof of concept and a lot of marketing dollars, and a lot of consultants are going to make money. But at the end of the day, we won't see any large-scale use of these technologies because they're trying to solve a problem that doesn't exist. If you have a consortium where participants don't trust each other, a blockchain may be a slightly better solution than a completely centralized database. And that's going to be profitable for the 5 banks that participate. But that just makes it a niche enterprise-scale technology that can be used by a very few companies in a very narrow set of circumstances within those companies. Sure, you can run stock markets in a more decentralized manner if you use blockchain. But the cost of that is that you're substituting human oversight and auditing mechanisms that are well understood with an obscure technology that is not so well understood, and you lose a lot of efficiency. And as a result, we haven't actually seen these deployed. So in all of those cases, it's not a good solution for a problem because the problem doesn't exist. The same thing you see for recording real estate in blockchains, which you can do with a centralized database, etc. In fact, the more centralized the type of solution you're trying to build, the less suitable a blockchain is, which is why central bank digital currencies will not use blockchains. Why? They don't need them. You don't need a blockchain to run the equivalent of government PayPal. You can run that on traditional off-the-shelf enterprise IT technologies much more efficiently. And if, after all, this is a centralized system that is controlled in a centralized manner, the blockchain doesn't add anything other than inefficiency. So the bottom result is you don't need a blockchain for that. In fact, I have t-shirts on my shop that say, you don't need a blockchain for that, because I said that phrase so often, or asked the question, why do you need a blockchain for that? So often in so many different circumstances. And if you want to answer that question, your answer had better be immutable, censorship resistant, decentralized, or some other thing like that. As for government corruption, if what you want is transparency and accountability, then what you want is audit mechanisms. And you can do that by digitally signing database audits on a regular basis and using traditional mechanisms of oversight. Blockchains don't make that any better. In fact, arguably, they make it worse. Because one of the characteristics that enables decentralization in blockchains is the anonymity of participants and the irreversibility of transactions. And therefore, they can lead to more corruption, more lack of transparency in the wrong hands. The wrong hands being the few hands, which is why these technologies only make sense when they're broadly distributed in as many hands as possible. That type of power corrupts when it is centralized and liberates when it is decentralized. So you want to have that power in as many hands as possible. So that's why you don't need a blockchain for most of those. Now, my opinion on this is definitely not a mainstream opinion. I would say it's shared by many other people in the blockchain space, especially in the Bitcoin space, who see this as a technology that is empowering for individuals, but not very useful in the enterprise environment. And don't get me wrong, I like enterprise environments. I spent the vast majority of my career working in enterprise IT, building large enterprise systems and doing security for large enterprise systems, including banking, finance, and government systems. I understand enterprise IT, and this technology isn't particularly useful in that context. It is useful in many, many other contexts. So, Michael has a follow-up question. Doesn't a blockchain offer opportunity to eliminate expensive intermediaries in doing business? Yes, but in centralized systems, expensive intermediaries are also called oversight and accountability. So many of the things that you would see as expensive intermediaries are the ones who are doing the oversight and accountability in order to ensure there isn't corruption. Like, for example, in a stock market environment, the clearinghouse is there to offer accountability, transparency, and auditability of the system. They are an expensive intermediary. Removing these and putting the operation of the market function itself in the hands not of an uninterested third party whose job is accountability, but in the hands of a consortium of banks who are cheating, stealing pigs who want to steal from each other and have every interest in corrupting the market function to enrich themselves, isn't efficiency. What you did is you just stripped out the only level of accountability that existed, and you took a function from the hands of someone who is not a market participant, but is a third party who does not have financial interest directly in the market, and you put that function in the hands of the people who are the market participants, who every movement of the market is either in their favor or not, and who have every motivation to corrupt the market function. All right, that's about all we have for today. There's some questions about elections and other processes like that. Anybody who works in information security will tell you that for some functions in life, especially things like that, like elections, when you have an environment when there is a vast gulf in the availability of technology, in the knowledge on how to use technology, electronic election systems are a nightmare. Even if they are secure, all of the participants will claim that they were hacked and that the election was stolen, as we saw recently. Even without any evidence, participants will claim they're stolen. And when they are stolen, it's impossible to reconstruct the evidence that the election was stolen because they are opaque and intransparent. Indelible ink on the tip of your finger and a paper ballot that you mark with a simple graphite pencil turns out to be a much better decentralized model for holding elections. It makes elections robust, auditable, and transparent with sufficient privacy without being able to steal them, because it's a very decentralized process with layers and layers of auditability. It makes it very slow to count the results, however. So efficiency is not the goal in elections. I disagree that blockchains are good for election systems. I think they're a complete nightmare. All right, that's all we have time for today. Thank you so much for participating in week 6. And I believe I have one more next week. I think it's my last week, and I will see you then. Have a great time. Do your studying over the week, and please send your questions in the forums so we can prepare and answer them for next time. Until then, I'm Andreas, I'm Antonopoulos. I've been answering your questions for this session for the massive open online course by the University of Nicosia's master's degree in digital currencies. Have a great weekend.